Good morning. Now we are going to cover the next part of the design of drop inlet spillway. So, we will going to continue with more design problem here in these slides. So, the problem number 1. So, determine the size of concrete pipe needed in a drop inlet spillway for a peak flow of 3 meter cube per second and a total head is assumed as 3 meter. So, determine the slope to be given to the pipe to flow full and the length of the pipe is kept as 12 meter. The entrance loss coefficient is 0.5 and the friction loss coefficient is 0.03. So, assume the downstream end of the pipe is kept around 30 centimeter below the upstream end. So, first we are going to calculate the velocity of flow in a pipe. So, this equations was already covered in slide number in earlier slide. So, here the velocity of flow is again a function of the coefficient of contraction and the coefficient at head loss at the entrance of the pipe, and this is again as you know this head, the velocity head is given by equation h equal to v square by 2 g. So, it is nothing but v equal to 2 g h, but since it is a pipe flow. So, we are this is the losses due to pipe flow. So, this factor is considered here. So, where K e is the head loss at the entrance, K c is the head loss due to the coefficient of contraction and L is the total length of the pipe. So, using that we can calculate directly the velocity of flow through the pipe. Now, as you know, the area is a function of the cross sectional area of the pipe is a function of the discharge and the velocity of flow that we calculated in the previous step. So, this one. So, from that we can directly calculate the pipe diameter. So, since the pipe, the cross sectional area of the pipe is assumed as circular. So, this is the circular cross section. So, the diameter of the pipe is calculated using taking into care that this is a circular cross section. So, here it comes the area diameter of the pipe as 8.82 meter. So, which is nothing but 80. So, since this is not a standard measure, so we select 85 centimeter of the pipe diameter. Now, we are going to compute the natural slope. So, natural slope is again a function of coefficient of contraction and the head loss, the velocity head. So, from that we calculated the natural slope of the pipe. Now, as you have given the downstream and end of the pipe is kept 30 centimeter below the upstream. So, from that information we can directly compute the actual slope. So, here, so this is in this way the downstream end is located at, this is the downstream end suppose and the upstream end. So, this is located at a height of 30 centimeter. And this is your the length of the pipe suppose. So, this is the pipe length which is given as 12 meter. So, from this you can directly calculate the actual slope. So, the actual slope is 0.025 and as you can see from the earlier slide, the natural slope is kept as 0.048. So, the natural slope is larger than the actual slope. So, this is the case of the condition 2 where the pipe will flow full. So, now coming to the second problem, a pipe of 1 meter diameter of a drop inlet spillway ends in a river which maintains a constant reduced level of 232 meter. Now, this is a graphical kind of problem. Now, plot the discharge curve for following data. So, inlet size is 1.2 meter diameter and 4 meter depth, and reduced level of the crest at the inlet is 241 meter, drop of the pipe is 6 meter in 75 length of the pipe. So, assume necessary data. So, some of the data is given as the coefficient of discharge for pipe flow is 0.80 and coefficient of discharge at the entrance is 0.61, and also assume that the entrance coefficient at loss is 0.50, the Ke is kept as 0.50. Now, this is the complete figure. So, this is kept as 241 meter and the diameter of the here at the entrance is 1.2 meter. So, this is at the pipe structure is here, the diameter is the pipe structure at the here the diameter is kept as reduced 1 meter, and this is the here the depth is around 0.5 meter. So, this is the 230, this height is the combination of 8.5 and 232.5 meter. So, this and this here is located the dam, and besides the dam this spillway is kept. Now, how you can the first part, as you can see. So, this is the diameter at the inlet is given here. So, based on that, first we calculate the flow through inlet. So, this is the flow through inlet, as you all know, is governed by wear flow. So, this is a wear flow equation. So, where C d is the coefficient of discharge and the length of the length of the pipe, and h is the velocity head, and the discharge C d is given, the coefficient of discharge is 0.61. And L, how we calculate the L? The length is calculated as the perimeter of the tube of inlet. So, the perimeter of the circular cross section is nothing but it is a function of diameter of the pipe multiplied by the pi. So, using that you can get a Q I is a function of h. Now, for different values of h, that is at different interval, like at an interval of 0.25, you can get the calculate the value of Q I, that is Q I is nothing but the flow at the inlet. Now, to maintain the principle of continuity, the flow of the inlet is equal to the flow of the outlet. The principle of to keep constant mass and momentum energy equation. So, Q I in this case Q at the outlet. So, the flow at the outlet is nothing but the discharge is a function of area, cross sectional area, which is we assumed as a circular cross section of the pipe multiplied by velocity, and to conserve the principle of mass, momentum and energy. So, Q I is equal to Q 0. So, now this Q is calculated as this one, and since the flow is very high. So, we assume that this is called as a coefficient of discharge multiplied by cross sectional area and flow at the velocity. Now, you can directly compute. So, the discharge coefficient of discharge is given by C d, which is in the problem is 0.80, and now it is since the pipe has a circular cross section. So, it is nothing but pi by 4 d square, and then you get the value of h dash. So, now Q I equal to Q 0. Sorry. Now, so you can equate the equation 1 that you already calculated in step 1 and equation 2 and then at various values of q I a table value can be prepared. So, that exactly was performed here. So, at different head value and suppose h equal to 0, the value of q I and q 0 was calculated and then you can plot it graphically for different h values. So, head over the crest. So, this is a head over the crest at different interval and what will be the value of q I and q 0 in QMAC it is plotted here. So, as you can see the q I here is the inflow flow at inflow is giving a parabola shape, more or less a parabola shape, where the outflow is generally a straight line or it kept more or less constant, where the inflow is maintaining a parabola shape. So, this is a inflow and outflow curves of the drop inlet structure. So, with these two problems I am going to end this lecture and thank you.